Hello everyone, MKS here. I hope you all are doing well in all the chapters before probability for class 12 syllabus. The chapter probability is very important for class 12 students. It was very important when you are in class 11, equally important here in class 12. 10 marks given for only probability distribution. 3 different types of distributions are there in your syllabus. We'll learn all these one by one. But before we start anything, we need to know random variable, what is a random variable in probability and its distribution. But before we start that also, we need to know what is there in CBSE syllabus for 2024-25. If you go to academic website of CBSE board, then you can discover this page, Applied Mathematics 11 and 12 code 241 session 2024-25. What is there in class 11 syllabus you don't need. Let us go for class 12 syllabus now. Okay, class 12 syllabus, all these units are done already. Unit 1 number, quantification, numerical application, algebra, then calculus, and then there is probability distribution. 10 marks given for that. You can see what you have to learn there, what is the topic, what is the learning outcome, and what topic exactly you are going to learn. It is probability distribution, mathematical expectation, variance, binomial distribution, Poisson distribution, normal distribution, all these come one by one, but today we will focus on the first chapter, which is probability distribution. Students will be able to understand the concept of random variable and its probability distribution. Find the probability distribution of discrete random variable. Definition and example of discrete and continuous random variable and their distribution. They should learn properly. So the content we are going to do today, that is probability distribution. Learning outcome will be understand the concept of random variable and its probability distribution. I will explain all these things. Find probability distribution of discrete random variable. Definition and example of discrete and continuous random variable and their distribution to be done. I hope all of you remember what is a random experiment. Random experiment already you have done in class 11, so many chapters on it done. So I expect that all of you remember it properly. Outcomes of random experiment not known. You can say what is going to happen, but it is a probabilistic situation. Maybe wrong or right. Then what is a random variable? If I consider a random experiment of tossing a coin twice, you have done it so many times. When you are tossing a coin twice, what are the outcomes over there? That is known as sample space. If you write the sample space, it's going to be like this: HH, HT, TH and TT. This is the sample space. Now, with this sample space, if we imagine there is a function which associates a point in the sample space or more than one point in the sample space to a real number, then that function will be referred as random variable. So random variable normally denoted by the letter x. In case of function we have written fx, but here for random variable we will be writing x as the random variable. This term comes with probability theory only. So not fx right now, it will be x only. So what x will do? The definition of function, all of you remember, it will behave like a machine whose input is there and corresponding output, at least one output you will get. Then x is said to be a function. So if we consider random variable x, why it is random? Because it is related to random experiment. It is random variable because it is related to random experiment, you know. And why variable? Because x assumes many values. Let me explain with this experiment, the simplest one. X is a random variable for this experiment, and what are the values it can assume? So you are taking the domain of the function as S here, and suppose the random variable denoting number of heads. Okay, then take an event over there, H8, two heads are there. So if you write the value of function with this input H8, the output is going to be equal to 2. Agree with me? Because two heads you will be getting. So x H8, I mean like fx, you write f2, f1 like that. No, here it will be x H8. X is a function. You have to adjust with this function right now, not with fx. X is the random variable, its input H8, then the value is 2. If we take x ht or th, then what is the value? This is going to be 1 because one head is there. And x tt, there is no head associated with this, so its value will be equal to 0. Then understand what is the random variable? It is random because related to random experiment. It is variable because it assumes values like this, which is a real number, 2, 1, 0. Another thing I'd like to make clear for you, that on this sample space you have defined a random variable. The coin is tossed twice. We have defined a random variable x over there. Question arises, is it possible to define another random variable for this experiment? Question arises, can we define another random variable for this random experiment? Yes, of course we can define. Let us define it. Let's understand with the simplest example here. That random variable I am going to take as y. Instead of x, I am taking random variable y. Suppose y denote, here x denotes number of heads. Here y denotes number of tails. Okay. So if I write y, value of y by taking h over there, no tail is there, so its value is 0. Y ht, what is its value? You can take th also. Its value is 1 because one tail is there, and y tt, its value is equal to 2. Clear? I hope all of you have understood. So for this random experiment of tossing a coin twice, if I ask you to define the domain and range for this function, here dom f going to be equal to the whole sample space, and range f, range of the function rf, is going to be these three values, 2, 1 and 0. So understand, x can be treated as a function which is random variable, it has domain and it has range also. So in this context, I would like to ask you one simple question which you might face in all examination, including your CBSE board examination in 2025. that what will be the codomain of the random experiment. I mean, of this random variable is a function. What is its codomain? I told you a random variable will associate a real number. Whole set of real number is going to be the codomain. So for this random variable, codomain is equal to R, the set of real number. The concept is clear. I hope all of you have understood. Let me take another example here. A coin is tossed thrice. X denote number of heads. I mean that random variable. This is random variable X. This is another random variable I am defining on the same sample space. Sample space, all of you know, S is equal to H, T. This way 8 combinations possible. I am not writing all because I'll just explain the concept of random variable. I mean action of two different random variables X and Y. X denotes number of heads. So if I ask you a question, what is the value of X when H is there? Obviously its value equal to 3 because 3 heads occur, number of heads you said, so X H will be equal to 3. What is value of X H T? This will be equal to 2. It's like this. This you have understood. Now defining another random variable Y like this. It denotes number of heads minus number of tails. So let us do the experiment by taking Y as H this time. This is going to be number of heads. Number of heads how many? 3. Number of tails? No. So the value is equal to 3. If you find Y H T, number of heads will be what? 2. Number of tails 1, its value equal to 2. If I take this one, Y T, what is its value? No heads are there, only tails, and that is 3 in number. So value is minus 3. Why have I taken this example? One similar example. Because just to tell you that value of random variable can be any real number. Positive, negative, 0, it doesn't matter. Any real number can be there. That can be associated with the random variable. Understand? Now let me tell you briefly the application of this concept random variable as a function in daily life. I am just taking one example where you are supposed to toss a coin 100 times. Somebody asked you with that coin, how many times you will get tail? Can you please tell me? Or if you perform the experiment, you tell me how many times you got heads over there. This is example 1, where you need the concept of random variable and the study based on the concept of random variable. Another problem, let me tell you, where suppose there is a urn containing 30 good items and say 10 bad items. I mean, this may be good in the sense, this may be rotten. Like in case of fruit, 30 good fruits are there which you can eat and 10 bad are there which you cannot eat. Suppose you are taking a sample of say 9 fruits from there taken. 9 fruits taken out. In these 9 fruits, if you want to know how many good fruits are there and how many rotten are there, that will be helped by, that you can find with the help of concept of probability distribution. Another example, let me take here. Suppose person is asked to toss a coin or a rolling of a dice, whatever you say. Condition given that is a contest between you and your friend circle, and healthy contest. You are rolling a dice, your chance is there first. If you get a prime number on the dice, then you'll win some rupees. If you get even number, then you'll win some amount. But if you get a number 1, then you have to lose, say per game, rupees 20. Then you are starting the game, you have some expectation from the game, how much you can win. That will be stated by probability distribution and its further studies. Wait for that, because I will be taking many sessions on probability distribution. I will discuss all these things one by one, step by step. Just showing you the syllabus for applied mathematics once more. Understand the concept of random variable and its probability distribution. Find the probability distribution of discrete random variable. So random variable, just you have learned. What type of random variable is this? Let us learn. There are two types of random variables. One is discrete, the other one is continuous. Discrete random variable has a countable number of possible values. An example would be result of rolling a die, where the possible values are 1, 2, 3, 4, 5, 6. This is discrete random variable. And this we have done in those 2-3 examples I have discussed. I showed you how random variable are taking values 1, 2, 3, 4, 5, 6, or even -3 value also you can take. So those are discrete random variable. Then continuous random variable are what? Type of random variable that has infinite number of possibilities, infinite number of possible values within a given range. That is called continuous random variable. Although we are not going to study today's class on continuous random variable, but little idea of continuous random variable you must know for all kind of examinations in future. Continuous random variable, actually this part is dealt with the concept of definite integration and not included in syllabus. Just remember this way. Here random variable can take any value within 2 or more given values. Like suppose in a community you are measuring height of boys in the community. Then in the community content, say 5 lakh people, you are taking data for say 1 lakh boys. Their height will be lying in an interval. Like their height may lie between say 4 feet to 6 feet. Okay. So you need an interval over there. I mean, random variable can take many values over there in this interval. Anything can be there between 4 feet and 6 feet. Or you are asked to find number of boys, their height lying between 4 feet and 6 feet in the community. So in that case, we use the concept of continuous random variable, but we are not going to do it today. We are doing the chapter which is known as probability. So far, probability is not discussed. I have discussed a random variable and its values, which is nothing but a function, its domain, range, codomain, all these are defined. Now see how the concept of probability can be introduced here. Let us take that experiment where you have tossed a coin twice. Let me take the simplest example first. The sample space when a coin is tossed twice given by HH, HT, TH and TT, you know. To get and that random variable you are taking, let it be X. X denote number of heads. Okay. What I am going to do there, I am not sure that all will come in the equal probability, no? And it is quite obvious, they will not come, all the outcomes will not come with the equal probabilities. So suppose when you are telling x denote number of heads, you are taking values of x equal to small x along this row. Random variable taking the value x. When a coin is tossed twice, what are the values of this random variable? Maybe no head is there, maybe just one head is there, maybe two heads are there. And let me write the probability of those possibilities here. So what is the probability of getting 0 head? X equal to x I am writing means I am taking 0 head over there. 0 head occur in which case? 0 head occur in this case. 2 tails are there. What is its probability? Out of 4 events, this is just 1. So its probability is 1 by 4. When you are writing 1 head, there are 2 cases. You all can see that probability is going to be 2 by 4. And here it is 1 by 4. Okay. When you are writing the values of random variable in one row and corresponding probabilities in another row in the form of table, then this is called the probability distribution of the random variable. This kind of tabular representation is called probability distribution of the random variable x over there. So what is probability distribution? Where you write values of random variable in one row and corresponding probabilities in another row. That is called probability distribution of the random variable x. Any random variable which you take, its probability distribution can be written this manner. First row contain values of random variable, second row their probabilities. So let me go for formal definition now. The probability distribution of a discrete random variable provides information about the likelihood of different outcomes for that variable. This is formal definition. Why do you need? Because when you are going to calculate, probability of any event over there or the values of random variable, then you have to keep in your mind that all possibilities are equally likely. They come with the equal probabilities. Like in the example of coin toss twice, I have taken probability of getting 2 heads 1 by 4. Head and tail, getting first head, second one tail 1 by 4. First one tail, second one head 1 by 4. And then with two heads it will be 1 by 4. Here it is 2 by 4 because 1 by 4 plus 1 by 4. So these events are all equally likely. They are outcome of random experiment. They come equally likely. They have equal possibilities. Okay. So in a probability distribution, we should keep in this our mind that they all come with equal possibilities. That's why the probability distribution of a discrete random variable provides information about the likelihood of different outcome for that variable. For a discrete random variable, we should remember that discrete random variable is one that can take only specific distinct value, just as discussing. Continuous one take any value in between two given, but a discrete random variable take distinct values only. Discrete random variable, some examples I have already given. Flipping of coin, tossing, rolling of a dice, and number of defective item in a production batch, all these things comes under this category. Probability distribution of random variable I explained with a simple example. But have you noticed one thing? That in that example, the probability of every event is greater than or equal to 0. Equal to 0 I haven't got here. But as per definition of probability, these probabilities are always positive. This you should remember. And second one, if you add all these things, if you add 1 by 4 plus 2 by 4 plus 1 by 4, sum of these probabilities is equal to 1. And this is in fact rule of probability distribution. All events are equally likely and sum of the probabilities of those events is equal to 1. So let me go for the formal definition of the probability distribution now. For a discrete random variable x, it is a list of each possible value of x along with probability that x takes that value in one trial of experiment. We'll solve many examples. Don't worry, the previous example is not very clear. I'm going to take so many examples for you. You'll definitely understand. So in other words, this will tell us how likely each outcome is. Probability must lie between 0 and 1. I told you it can never be negative. It cannot exceed 1 also. The basic concept of probability. Sum of all the probabilities equal to 1. Clear? Now suppose the random variable x taking values x1, x2, x3, xi, xn this way. These are values of random variable x. Corresponding probabilities are px equal to x. You have taken x here, small x1 because of that. This one p1, p2, p3, pi and pn. If you write all these things, the first row contain all values of x, the second row contain all probabilities, then this is called probability distribution. I hope none of you have any confusion about this. Okay? But if you don't understand, it will become your nightmare. So you need to understand all these things properly. So if this is a probability distribution, then the first part you should remember that pi for any particular probability event, it should be greater than equal to 0, less than equal to 1. And second one, that sigma pi equal to 1. Okay? So if this condition is not obeyed, then it will not be probability distribution. We will see some problem where this condition may not be obeyed. So this will not be a probability distribution. Just let me write one arbitrary case. Suppose I am taking x equal to x, here this man. The value of random variable x 0, 1, 2, 3 and probability of x equal to x I am writing say minus half, 2/3, 3 and 1/4. This is not possible. Why this is not possible? Because it is not obeying the condition of random variable. That one probability you have got minus 1 by 2 over there. This is not possible. One probability you got greater than 3. It does not lie in this interval. It is not a probability distribution. And thirdly, sum of these probabilities is never equal to 1, exceeding 1. So this is not a probability distribution of a random variable. Clear? Now this is the time to show you many examples. But before we start, let me tell you something about the support material provided by CBSE. That also you can find. I'll tell you the link of the support material later on. That support material and two famous books are there in the market, M.L. Agarwal and R.D. Sharma. You are confused what to do. How many sums should I do? My advice for you, don't listen to anyone in this world. You follow NCERT support material sums first. All the numerical examples, even solved examples and exercise problem, you must do from NCERT support material. Past 3 years, applied mathematics experience I'm sharing with you. no concept outside that support material will be asked in final board examination. So this is your duty to finish it first, and then you go for ML Agarwal book or Dishomo book. You can do both of them, you can do one of them, but NCERT support material is a must for you. So what I am going to do you here today, I am using my experience. Past 3 decades of teaching experience I am using here for you. Here I will be discussing those kind of sums which can give you trouble, kind of sum which is important for you. I am not solving sums from any specific book. Okay, some sums came in my mind, some sums are collected, but not from a particular book. This you should remember. So let's start without wasting time. Let us see this example first. Bag contain 2 white, 1 red balls. One ball is drawn at random and then put back in the box after noting its color. Process is repeated again. If X denotes number of red balls recorded in 2 draws, describe X. This is not probability distribution. It just describe X as a random variable, X as a function. Write the domain, write the range here. Okay. Domain is the sample space. And those 2 white balls in the urn, first we name as white 1, white 2. And the red ball we are taking as red 1. So what are the outcomes over there? The way they comes, it matters. First one white, second one white. Okay, you understand? First one may be white, then second one also white, but this white ball, they are distinct, and this is the other white ball. Maybe like this also. W2, I mean second white ball comes first, then W1, first one the first ball, second trial also the first ball. So all the possibilities here I have considered with the white balls only. And then I am starting with red ball. Red ball, what are the possibilities? First one red, second one also red. No other possibilities there. Now white with red combination, outcomes will be like this. White 1, red 1. Maybe red 1, white 1. Maybe white 2, red 1. Maybe red 1, white 2. All these are different outcomes. All these are different outcomes. Their probabilities you have to consider separately. Probability distribution is not asked here, but let us do it. That probability distribution also will do here. So random variable denote what? Number of red balls. What are the values you guess the random variable going to get? X may be 0. 0 means X may be 0. It means what? 0 red ball. X may be 1 red ball. X may be 2 red balls. So if you draw the table here, that for the purpose of probability distribution, that X equal to X first row, P X equal to X in the second row. X equal to X. What are the events over there? That is 0. 0 means no red ball. 1 means 1 red ball. 2 means both the time you are getting red balls. It's like that. Let us write all the events associated with 0. No red ball, so it includes these 4 events. Okay. So it will be W1, W2, W2, W1, 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 W2, W2. And here 1 red. 1 red, how many cases? This one, this one, this one, this one. So it includes W1 R1, R1 W1, W2 R1, R1 W2. And this one, both the time rate, it is R1, R1. Clear? You can write the probability easily. How many cases are there? 9 cases are there. So probability here it is going to be 4 by 9. How many here? 4 by 9, and this is 1 by 9. What's the sum of the probabilities here? That is 4 by 9, 4 by 9, 1 by 9. This is 1. No probability negative. No probability greater than 1. So it is probability distribution. What is the domain of this random variable? Domain of the random variable is the whole sample space. And range going to be what? Range contains these values only, these 3 values. I hope you have a crystal clear idea now on the values of random variable, how related to a random experiment. Let us go for next problem. 2 cards are drawn successively with replacement from a well shuffled deck of 52 cards. Find the probability distribution of the number of aces. So how many aces you expect? If you are drawing 2 cards only, then you expect maximum 2 cards. Ace, not more than that. So let me write the values of random variable here first. Random variable let us take as x only, and in the first row we are writing x equal to x. Probability x equal to x will be writing here. So what are the values of random variable here? That may be x equal to 0. I mean just write 0. It may be 1. It may be 2. What is probability of 0 s? No s is there. How many s's are there you know? 4 s's are there. 4 s's. This I need not explain. You have learned before. And 48 other cards. Okay. Now for 0 aces, there will be 48 C4 divided by 52 C4. Why? Because no ace is there. That's why 48 C4 by 52 C4. Evaluation of all these things will be done by this formula. NCR equal to factorial n by factorial r, factorial n minus r. What about the second case? There is 1s. It will be 4c1 and 1 from others, that is 48c1 that divided by 52c4. And this one is both are s's, so it will be for 4c2 divided by 52c4. Clear? If you find the values of 48c4 by 52c4 here, then the result going to be equal to 188 by 221. This will be 32 by 221, and this will be 1 by 221. Just use this formula and put the values in every case, then you will get this. This is a probability distribution. Because some of the probabilities I can see here, it is going to be equal to 221 by 221. Answer is 1. No probability negative or exceed 1. Find the probability distribution of number of doublets in 3 throws of a pair of dice. Pair of dice, their outcomes you know very well. 1, 2, 3, 4, 5, 6. For the second die also 1, 2, 3, 4, 5, 6. Okay. So doublet means it will be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. These are doublets. You have to find the probability distribution, not probability only. of number of doublets in 3 throws of a pair of dice. So when you are doing 3 throws of pair of dice, then what are the outcomes of random variable? Let x be the random variable. Then what are the values of x? That you have to decide. It can be 1, it can be 2, it can be 3, it can be 0 also. Isn't it? Because 3 throws a pair of dice. You may not get a doublet. That is one case. 0. You may get one doublet once only. You may get twice. You may get thrice also. So first row x equal to x. It is p x equal to x. Now, when you consider total number of cases here, number of cases going to be what? Number of cases will be 6 into 6, 36. So probability equal to what? This is going to be 6 cases only doublet are there. 6 by 36. 1 by 6. Clear? So if I take probability as P, then P is 1 by 6. Probability of non-occurrence of the event we are taking Q, it will be what? 1 minus P, that is 1 minus 1 by 6. Why non-occurrence is required? Because we know multiplication rule of probability. We are going to apply it. So let us go in details. When you did not get any doublet, then what will be the probability? No doublet you got here. It means it is going to be product of this event Q, Q and Q, that is 5 by 6 into 5 by 6 into 5 by 6, 125 by 216. Clear? No doublet, no doublet, no doublet. Their product. Conditional probability, this product we have already learned. When there is one doublet, then that one coming when? That you don't know. That doublet coming in first trial or second trial or third trial. So I am writing, suppose you get it in first trial. 1 by 6 raised to 5 by 6 into 5 by 6. Now suppose you get doublet in the second trial, then first trial probability is 5 by 6, you haven't got 1 by 6 and again 5 by 6. Then you are getting two doublets. Maybe first two, 1 by 6, 1 by 6, third one not. Maybe you got first and third, not the second one. Maybe you got second and third, not the first one. Can happen this way. And then you are getting all three doublets. What will be the probability? 1 by 6, 1 by 6, 1 by 6. Now add all these. This is going to be what? 25, 25, 50, 50 by. This is going to be what? 15 by 216. This is going to be 1 by 216. Clear? Let us check the probability here. This time doublet can come here also. I forgot to take that into consideration. So there may be 5 by 6, 5 by 6, 1 by 6. So it is 75 by 216. So what is the sum of these probabilities? This plus this plus this plus this, it's going to be equal to 1. Clear? And no probability less than 0 or greater than 1. So it is a probability distribution in the given example. On contain 4 white and 3 red balls. Find the probability distribution of number of red balls in 3 draws with replacement from the urn. 4 white and 3 red balls are there in this urn. Make it closed, because if you are doing some probabilistic experiment, it is not exposed to you, no? Find the probability distribution of number of red balls. How many red balls are there? 3 red in total. So, if we write x, the value of random variable in the first row, it can take 0, it can take 1, it can take 2, it can take 3 also. We have to write Px equal to x here. Don't be confused. It is just symbolic. Probability x equal to x means probability when random variable take the value 0. And you are doing it for what? For red ball. And you have drawn it 3 times. None of the cases you got a red ball. You are getting white ball only. So probability going to be what? That will be 4 by 7. I am using multiplication rule. Answer is 64 by 343. Okay. Next one, like the previous sum. If you are getting a red ball, what time it is coming, it matters. You are getting the red ball in the beginning. So 4 by 7. No, red ball in the beginning means it will be 3 by 7. Other two cases you haven't got. 4 by 7, 4 by 7. Then next time 3 by 7 coming here. 4 by 7, 4 by 7 rest. I mean plus 4 by 7. Then 3 by 7. Then 4 by 7. Third ball may come in the third draw only. I mean red ball may come in the third draw also. So this will be 4 by 7, 4 by 7, 3 by 7. So same product, only just written twice. Alright. So 48 by 343. This is going to be 144 by 343. And next you are getting twice. 3 by 7 coming twice. So combination may be like this. 3 by 7, 3 by 7, 4 by 7 plus 3 by 7, 4 by 7. Same way, same way. There is no difference. And then 4 by 7, 3 by 7, 3 by 7. What I am doing there? I am just considering all the cases when 2 red balls are there. See, this is the case of getting a red ball here, case of getting a red ball here, then 4 by 7. The same manner, you add all these things. The result going to be what? This is 36 into 3. That is 108 divided by 343. And then all 3 cases you are getting red ball. It is product of 3 by 7, 3 by 7 and 3 by 7. 27 by 343. Clear? You add all these now. So sum is coming equal to 3. Every time you can check. Then this is coming 4 and this is also 3. So result is 1. All the time that probability, sum of these probabilities should be equal to 1. Never be confused. Here the problem is a bit different. Find the probability distribution of number of successes in 2 tosses of a die where a success is defined as a number greater than 4. Understand the sum? In 2 tosses of a die where a success is defined as a number greater than 4. Number greater than 4 means Sample space contain these 6 points 3, 4, 5 and 6, and you are tossing it twice. So problem is no doubt similar to previous one. Why? If we start writing the value of random variable here, then you can get number greater than 4 twice. You can get once and you are not getting it at all. So this x value may be 0 when you are not getting at all. It may be 1 when you got it once only and it is twice. Now probability of x equal to x you have to write here for 0 case where you are not getting a number greater than 4 at all. I mean 5 and 6 you haven't got. Then what will be the probability? Probability of getting 5 or 6 is 2 by 6, 1/3. Then probability of getting not a 5 or 6, I mean 1, 2, 3, 4, this is going to be 1 minus 1/3, that is 2/3. Clear? So when you are not getting it, you can get probability here 2 by 3. This multiplied by 2 by 3. Why? Because first time you are getting number not equal to 5 and 6. Second time also not equal to 5 and 6. Going to be like this. It may come once. So first case you are getting this one, this probability. Second case you are not getting. Or first case you are not getting 5 or 6. Then you are getting it. So 2 by 9, 2 by 9, it will be 4 by 9. Clear? This result going to be equal to 4 by 9. Okay? Now, when its value equal to 2, you are getting 1 by 3 into 1 by 3. Probability is 1 by 9. Clear? So sum of these probabilities again going to be equal to 1. So this one is a probability distribution. X represent the difference between the number of heads and number of tails of 10 when a coin is tossed 6 times. What are the possible values of x? This time I haven't asked probability distribution, just I wanted to explain the sum. It represents difference between the number of heads and number of tails of 10 when a coin is tossed 6 times. So how many times maximum you can get number of heads? You can get all 6 times heads only. Okay. So this may be 6, this one 0. You can get heads 5 times and number of tails once. You can get it 4 and then it is 2, 3 and then 2. Okay? No, it will be 3. So what are the values of random variable x? Problem may arise this manner also. So let us know how to get the values of x. X will be difference between these two. So this is going to be 6. It may be 5 minus 1, that is 4. It may be 4 minus 2, that is 2. It may be 3 minus 3 is 0. So values of x will be like this, and you might have to calculate the probability of every event and then make the table according. This is not a difficult one, but just I wanted to explain the meaning of this, how when it represents difference between number of heads and number of tails, then can it be a probability distribution? Can we define it? Yes, of course we can. Now for probability distribution, we just take the values of x like this and write the corresponding probabilities. When 6 there, 0 here, 5 there, 1 here, it's like this. Okay. 2 bad eggs are mixed accidentally with 10 good ones. Find the probability distribution of the number of bad eggs in 3 drawn at random without replacement from this lot. Okay. So bag contain 2 bad eggs, not edible, and 10 good and 2 bad. Okay. You are taking 3. Sampling of 3 is being done. Then probability distribution of number of bad eggs. In these 3 eggs, how many bad eggs can be there that you account for this? I mean that x equal to x you take here, px equal to x like previous example. X can take 0, can take 1. It can never be equal to 3 because 2 bad eggs only there. How can you get 3 bad eggs from there? All they are taking 3 from there. You have to consider probability accordingly. I will not solve the full problem here. I will just give you the clue to solve it. Just out of these, getting a bad egg, what is the probability? It will be, total is 10 plus 2. So in the first case, if you are getting a bad egg, then probability will be 2 by 12. Probability of getting a good one, in the beginning it will be 10 by 12. It's like this. But you are selecting eggs one by one. Problem going to be more difficult here. I mean, big one, not difficult, big one. 0 bad egg, no bad egg is there. So what will be the probability? 3 trials you have to do. First one is good one, this is for good one, and this is for bad one. So we are going to find probability of good, good and good. No bad egg is there. So what will be the probability here? First one good, what's the probability? 10 by 12. Second one 9 by 11. Third one 8 by 10. Just simplify it. You will get the answer of this case where no bad egg is being drawn. But when bad egg enters, that bad egg comes in which draw, that you have to find. It will be probability of bad, good, good plus probability of good, bad, good plus probability of good, good, bad. How do you find this? Bad. Bad one probability is what? 2 by 12, then good one. 10 by 11, then good one. 9 by 10 plus good. What's the probability? Then bad. Bad how many? 2. 2 by 11. Then good. 9 by 10 plus good. First one. 10 by 12. 9 by 12 and then bad one. It is 2 by 12. Hope you are understanding this situation. Next one. There are 2 bad eggs. I mean, situation may be like this. Bad, bad, good. Alright? Separate these 2 cases. Maybe good, bad, bad. Another case, just maybe bad, good, bad. So probability going to be bad one. Probability is 2 by 12. Then bad one again, 1 by 11. Then good one. 10 by 12 plus good. 10 by 12. 2 by 11. This plus bad, good, bad. So there will be 2 by 12. Then what? 10 by 11 into 1 by 10. So Px equal to 2, sum of all these cases. Of course, I am not going to do. Px equal to 1, sum of these three cases. Px equal to 0, this case. Their sum will be equal to 1. This is your task to find. Try at home. A very interesting question I have taken here. Coin is tossed until a head appears or the tail appears 4 times in succession. If head occurs, then you stop the game. If head is not coming, game will be continued. Till when? Maximum how many times it can continue? It can continue till 4 times. If you get all 4 tails in succession, then stop the game. So the sample space contain these 4 points. H, maybe first one tail, then H, then you stop the game. Maybe second one, first one tail, second one tail, then H. Maybe T, 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 H. You cannot do more than that. Am I correct? Just think. So this is a bit difficult to think. Game will be stopped over there when you get a head. If you get first time, then the game is over. If you get it second time, then first time you have got a tail, game is over. If you get a head over there, then first 2 times you haven't got it. Third time you are getting. Stop the game over there. So this is either or case. Either this will happen or this or this or this. So we have to write the probability distribution column. Probability distribution for such a random experiment. So you are getting in first trial, then it is 1. You are getting in second trial, then it is 2. You are getting in third trial, 3. You are getting in last trial, it is 4. You cannot do more than that. When you are getting first time, it is head only. What is its probability? This is going to be 1 by 2. When you are getting tail first and then head, what is the probability? Tail first, then head, half into half. Game is over. But if you don't get, then tail, tail, head, the probability will be half, half into half. And then this case. Half, half, half for 3 tails. So this is half. This is 1 by 4. This is 1 by 8. And then 1 by... Now I did a mistake over there because when this case arises, the 4th time you are getting head, then you are confirmed that you are getting a head over there. No need to toss the coin again. If you get tail, then also it is over. So probability of these 3 cases only will be there. Got the point? When you are getting 3 tails, 4th one head, game automatically over. 4th one tail, game then also over. But it is not a probabilistic situation. Getting 4th trial, whatever head or tail, it doesn't matter. Game will be over. Whether you are getting head or tail. So probability will be 1 by 8. 1 by 8, 1 by their sum is 1. So it is the probability distribution of number of tosses. This kind of problem may arise where values of x given in tabular form, px also given. Then you have to find the value of k and probability in the respective cases. You may be a bit confused. Let me take the table this way, horizontally. If you draw it, it's going to be like this. For 0, the probability is 0. For 1, 2k, 2, 3k, 3k. Then for 4, 2k, 5k square, 6, 7k, 7, 2k square plus k. First you have to decide the value of k. How do you find the value of k? The value of k can be obtained if we remember the definition of probability distribution, that sum of these probabilities is going to be equal to 1. So 0 plus 2k, 3k plus k square plus 2k square plus k should be equal to 1. So it is 710k square, 5, 6, 8, 9k equal to 1. This implies 10k minus k minus 1, 0. So 10k minus 1, k plus 1, 0. K equal to 1 by 10, k not equal to minus 1. Clear? So the value of k minus 1 you cannot take. Then this probability, sum of the probability is going to be negative. That is not possible. Probability cannot be negative. Value of random variable can be negative. Now when you are going to find p, the first part you are going to find, say p x less than 6. How do I account for this? P x less than 6. Less than 6 means sum of these probabilities. That is p x less than 0, x less than 1, x equal to 0, x equal to 1, sum of all these cases, it will be 0, 2k, 3k, k. So this is nothing but 8k plus k square. Put the value of k, 8 by 10 plus 1 by 100. So 81 by 100 can be found this way. P x greater than or equal to 6, how do you find? You can find it from table. That is 7k square plus, this is nothing but 9k square plus k. That is 9 by 100 plus k is 1 by 10. So this is going to be 10, that is 19, 0.19 is the answer. Clear? And px greater than 0 less than 5. How do you find the third part? Px greater than 0 and less than 5. Greater than 0 and less than 5 is covering these four things. That is 3k. No, first one is 2k. 1, 2, 3, 4. It will be 2k plus 3k, k plus 2k. So answer is 8k. That is 8 by 10, 0.8. Okay? And person plays a game of tossing a coin thrice. For each head, he is given rupees 20 by the organizer of the game. For each tail, he has to give rupees 10 to the organizer. So something like betting. Okay? This is not betting. I don't want to take the name of that event. This is just a condition. Organizer, you are friend only, you are going to play over there. X denote the amount gained or lost by the person, so that X is a random variable and exhibit it as a function on the sample space of the experiment, right? The domain and range. So how to solve this problem? Is this a simple one or not? This is a simple problem. Here just you have to find the values of the random variable. Okay, what real number associated with it? Problem you can easily solve if I just tell you the values of one or two random variable. Coin is tossed thrice. All of you know sample space contain 8 points. H, 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 T, this way up to T, T, T. Okay. So what is the value of random variable when it takes, this is the sample space and this is the domain only. If it takes H, 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 then he will gain only by some calculation. If he just getting here in all three cases, then he is going to win. How much? Rupees 20 all 3 times. So it has value 60. Now when he is getting 2 heads 1 tail, H, H, T, T, H, 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 T, H, and is there any other case? 2 head and 1 tail, 2 heads and 1 tail. What will happen in this case? Either this or this or this. He will win in 2 cases, but he has to lose once. It is rupees 30. And then X, 2 tails and 1 head also there. So the value of this game is going to be what? Losing twice. 2 into minus 10 and getting a rupees 10 once. I mean, this is TTH, THT and HTT. This will be HTT. So losing twice, so this time it is 0. Value of the game 0 over there. Here it is 30. Whether it is getting this or this or this. And here it is 60. This kind of problem also may arise. Clear domain? Domain is what then? And then another case I forgot to tell you here. Let me finish it. Tail, tail, tail. Expectation negative. He is losing the game. All 3 times he is getting tail only. This will be minus 30. Rupees 30. Okay? This is of course a probability distribution. This is the domain. And what is the range over there? Range of the random variable. Range is going to be these 4 numbers. 60, 30, 20, 60, 30, 0 and minus 30. I have tried to explain all those types of sums available in those 3 books, that NCERT support material, Emil Agarwal and R.D. Sharma. If you have any problem in solving any sum from there, you must inform me right in the comment box. I will solve it for you, definitely. Thank you for staying with me till the end of the session.